Hey everyone, welcome back to Spark Talk, brought to you by the Spark branch of Electronics Club at University of Murtua. Today, we're diving into yet another exciting project, and it is Spark Micromouse project happening here at the Electronic and Telecommunication Department. Joining me today are the project chairpersons driving this build, Ruchira Bevardhana and Dandu Dabare. Guys, welcome to the podcast. So let's jump right in. For anyone who has never seen one of these, what exactly is a Micromouse?
Micromouse is one of the longest and the oldest robotic competitions that's in the world right now. It started back in around 1970s and still active today as well. So in a nutshell, Micromouse is a small autonomous robot that's trying to solve the maze completely on its own.
So let's talk a bit about the history of Micromouse and how all of this started.
So it started in 1952. A mathematician called Claude Shannon developed an electronic mouse that's capable of solving a maze. At the time, the processing part was not inside the mouse itself, it was inside the maze. So using a network of relay switches, the maze was capable of acting as a computer, and it was capable of solving the paths and guiding the Micromouse on the paths that it has calculated. So at the beginning, processing unit was not inside the mouse, it was inside the maze. But about 25 years later, the IEEE saw this maze solving electronic mice. So, but at that time, instead of using the processing unit inside the maze, they thought of integrating that into the mouse itself. So that shift of processing unit from maze into the mouse started an international competition, what we now know as the Micromouse competition. That's how the Micromouse competition gradually started.
Okay, so when we say mouse today, what are we actually looking at? Are we talking about a glorified remote control car or something else entirely?
So a Micromouse is a small robot that fits in your palm. So it has motors to move, sensors to detect walls, and a battery to power up the whole thing. And also it has a processor to make decisions on its own.
Wait, so zero remote control. So once you let it go, it's completely on its own?
So once you start it, the Micromouse has to explore and navigate through the maze and figure out the fastest way possible to solve the maze.
Physically, what are we looking at here? What does the actual maze look like?
Right, so it's a square grid, usually 16 by 16 cells. So each cell is the same size, and there are thin walls separating them, and the corridors are just wide enough for the Micromouse to pass through.
Does the mouse get any kind of blueprint beforehand, or does it have to figure out the whole thing out from scratch?
Right, so before the competition, the mouse does not know the maze, so it has to kind of explore the map, and it will be given a chance to go for a search run. And after that, it can kind of build up a map on its own and figure out a way to solve the maze.
Well, that's the crazy part to me. In the real world, autonomous robots uses GPS or LiDAR to map their environment, but in a tiny enclosed maze, I don't think you have the luxury. So how does this robot actually process its surroundings and figure out where it is?
Right, so there's no GPS or external cameras or anything. What it has is the simple distance measuring sensors, for example, like infrared sensors. So basically, it will detect whether there's a wall in front of the Micromouse, or left or right. And based on those information, it will kind of figure out a way, build a map on its own and figure out a way to solve it.
Well, if it's basically just looking for walls and moving cell by cell, why is the competition so intense? What actually makes it so hard to win?
Because in this competition, everything comes down to milliseconds. Even a slight difference in control systems, algorithmic decisions, or in the speed of the Micromouse can decide which Micromouse will win or lose in the competition. So, and as a matter of fact, the exact question you asked was already raised on 1980s in the Micromouse communities, mainly because algorithms that were used to find the shortest path were well known, and the sensors, microcontrollers that were used to design this Micromouse were becoming common. So they thought that there is no need to keep this competition ongoing. There is no challenge to keep this competition going. But that opinion changed at a competition that happened on 2017. The competition was named All Japan Micromouse Competition. So both silver and bronze places, robots who places silver and bronze, was able to find the shortest path and was able to make the run in about 7.4 seconds. But the winning mouse, it was called Red Comet, took a different approach. He did not use the shortest path, but it took a longer path that's about 5.5 meters longer than the shortest path that was in the maze. But mainly because the Micromouse isn't supposed to find the shortest path, it is supposed to find the fastest path. So algorithm in the Red Comets was able to decide that the longer path that it has identified has fewer turns than the shortest path. Therefore, it was able to gain higher speeds and smoother motions through that path. Therefore, he was able to take the first place on that competition by around 131 milliseconds. So, Micromouse has improved a lot in the past. It's improving right now as well, right now as we are speaking, and in the future as well, it will improve a lot. So Micromouse is not a simple competition. It's far from simple and it's far from being solved. So that's why these competitions are still going all around the world.
So where is this thing actually happening? Is it just a massive global thing, or do we have a local scene for it here in Sri Lanka too?
Yeah, so Micromouse is a global competition and many competitions happen throughout the year. So in Japan, USA, Portuguese, Singapore, there are many competitions happen. And in Sri Lanka as well, there are competitions happening mainly through university organized robotic competitions. One of the main robotic Micromouse competitions that's happening in Sri Lanka is RoboFest. It's been organized by SLIT. And also another one is Micromaze that's been organized by IEEE student bodies in IIT. So those competitions give a better exposure and experience to the Sri Lankan students to experience these real world Micromouse competitions.
All right, so let's talk about our ENTC team. What exactly is the Spark Micromouse project doing differently in this space?
So what we are trying to do is design a Micromouse platform that is open source. So everyone has access to the designs, hardware designs, software designs, and all the algorithms that we have developed. So they can use those to learn about the Micromouse, and then they can use them to further improve their designs. So basically what we are trying to implement at the end of the day is a robot, Micromouse robot that can that can solve a standard Micromouse maze that is modular, easy to understand, and anyone who is robotic enthusiastic can dive into these designs and further improve it. That's our final end goal.
That's a bold move. Usually in these robotics competitions, everyone hides their data structures, algorithms, and PCB designs to keep their competitive edge. So why give all that hard work away and make it open source?
As you said, almost all the designs that are competing in the competition, they don't have to disclose those designs. So Micromouse is a really way to any robotic enthusiast to dive into this robotic world. So but the Micromouse is a complex, as we have talked about, it's a complex task. So it has a higher entry barrier. So what we want to do is that remove that barrier, so that anyone who is interested in diving into these Micromouse projects, they can easily start it. So we are making open source. They can learn about the designs, then improve it from there.
Where are we right now in this project?
Yes, so right now we are in the implementation phase. So instead of building everything at once, we have divided the Micromouse project into a couple of subsystems, and we have assigned different teams to work on those subsystems. So they'll be working parallelly. So those systems are power system, motor, sensors, algorithm development and simulation, hardware implementation of the algorithms, and the control system.
Dividing the hardware into separate subsystems sounds great in theory, but getting the firmware to actually sync up across all of them without bottlenecking must be tough. So how are you guys testing all of this simultaneously without it turning into an absolute debugging nightmare?
Each subsystem has their own dedicated PCB. So instead of trying to go and build everything at once, so they will be working on their PCBs parallelly, and it will be much easier for us to identify any issues, and also it will make troubleshooting more easier. So once we are confident that each of these are working reliably on their own, then we will try to combine everything and design one single hardware and like complete the whole system.
I want to ask, are you guys just building the mouse itself, or do you have a way to actually test it locally?
We are developing the maze as well. We are developing an 8x8 practice maze, so it's like half the size of the original mazes. So we are developing that as well, so we can test our PCBs, we can use test runs, and it will be a shared resource for the department as well. Anyone who is developing a Micromouse can come and test it in the maze before running it on the competition itself.
So finally, I want to ask, what's your ultimate end goal? Once the firmware is stable and the integrated board is done, what do you want other students to do with this platform?
So the main idea is that we hope that these Micromouse designs become more approachable for anyone who is enthusiastic about robots and who wants to get into these Micromouse competitions. We want to make it approachable. That's our end goal. And if our design makes anyone make their first robot, or a team that's going to compete in a competition, if our design help them save time rather than just doing the basic again, they can import our basic design and they can improve it further, so they have more time to work on advanced things that will help a lot more when going for the competitions. So if that happens, that's our end goal.
I love that. Taking the entry barrier away so that the next team could work on making it faster instead of working on the basics all over again, like you said. So thank you both for taking your time to be here and walk us through the project. It's an awesome initiative. And that's a wrap on episode 2 of Spark Talk. A massive thank you to the Micromouse team and all of you who are tuning in across all the platforms. And we'll be back next time with just another great project happening in our department. So until then, keep building, stay curious. This is Spark Talk.